Alright, let's go over example 5 of finding the domain of quotient of two functions. In this case, we have f of x equal to x minus 5 raised to the third power and g of x equals square root of 5x squared plus 3. The domain of the function f is of course all real numbers because we don't have any denominators. For the function g, it's a little tricky because the first thing that you guys tend to do every time you guys see a square root function is that you guys tend to take, and not you guys, we tend to take the inside of the radical, which is 5x squared plus 3, and we set it not equal to 0, and then we solve for x. But by doing that, I get down to x greater than or equal to square root of a negative number. Now that's actually against the rule of taking the square root of a number, because in order to take any even root of a number, that number must not be negative. But I have an even root of a negative number. I know that any even root can only have either at least 0 or above 0, meaning it can only have 0 or any positive number underneath the even root radical. So that's why this work is not how we find the domain of this g of x function, but it is more like recognizing the fact that the graph of the function g of x is just an upward opening parabola. So the domain of the function g is also all real numbers. Now let's go ahead and find f of x over g of x. Well, f of x is 2x minus 5 over 3, and g of x is square root of 5x squared plus 3. And of course, at this steps, we have a rational expression. So what we tend to do is that we tend to take the denominator, set it not equal to 0, and then we solve for x. So let's try that. So we take the denominator, 5x squared plus 3, and set it not equal to 0. Take the exponential power of 2 on both sides. We got 5x squared plus 3 cannot be equal to 0. Subtract 3 to both sides. We have 5x squared cannot be equal to negative 3. Divide both sides by 5. We get x squared cannot be equal to negative 3 over 5. Take a square root to get x by itself, and to get rid of the exponential power of 2, I get x cannot be equal to the square root of negative 3 over 5. But hey, again, we cannot have any negative number underneath any even radical. So really, we actually don't have any restriction in this simplification process right here, because although this is a rational expression, the denominator of this rational expression is always going to be positive, hence the graph here, because if you take a look, the y value is going to go from at least being this point all the way to positive infinity. And of course, it never touches 0, so we can tell right away that the denominator of this rational expression is always going to be positive. So really, there's no restriction in this simplification process at all. So, and we'll sketch it out in a bit, but let's just go ahead and find g of x over f of x, which is square root of 5x squared plus 3 divided by 2x minus 5 raised to the third power. And of course, let's repeat the same way of finding the domain of a rational expression, which is taking the denominator and setting not equal to 0, and then we solve for x. So from here, we're going to take the cube root to get rid of the third exponential power. We got 2x minus 5 cannot be equal to 0. Add 5 to both sides. We got 2x cannot be equal to 5. Divide both sides by 2. We get x cannot be equal to 5 over 2. So this is the restriction of this entire simplification process. And of course, quick note, we don't have any restriction from the domain of f and from the domain of g. So we're good on that. Okay, now what about on a number line? What is the graph going to look like? Well, on a number line, let's sketch the domain of f over g first. Well, we know the domain of f over g is going to be all real numbers because as mentioned earlier, we don't have any restriction from domain of f, from the domain of g, and from every step of the simplification process of the quotient f over g. So putting everything together that I just mentioned, the domain of the quotient f over g is also going to be all real numbers. From negative infinity all the way to positive infinity. What about the quotient g over f? Well, on a number line, we're going to go ahead and put, let's see if we can see it right here. We're going to put 5/2 in there. And of course, you guys know why. Same as usual, domain of function f and domain of function g are both all real number. And because all of the restrictions that we have from the function f domain and the function g domain, and from the simplification process of the quotient g over f, RGS x cannot be equal to 5/2. So putting the open circle at 5/2 and collecting all of the x values in common of both domain of f and g, and all of the restrictions that we just mentioned earlier, the domain of the quotient g over f are going to be all real numbers except x cannot be equal to 1/2. Now the interval notations can be completed, and we can be created by the same fashion that we did earlier. Go from left to right, from negative infinity up to 5/2, but not including 5/2. Put the u inside to go to the next part, from 5/2, but not including 5/2. We go all the way to positive infinity. And that completes the problem.